Now, welcome back, everybody. Let's take more questions on vectors. This is May, June 2008. The magnitude, that's number 1, start from A. The magnitude of a force x1, xi plus 15j is 17 newtons. Let the force be F, and it is xi plus 15j. Its magnitude is 17 newtons. Now, question A says find the possible values of x. The magnitude is given by x squared plus 15 squared, and that value is 17, and that simply means x squared plus 15 squared, which is 225, equals 289. That's what you get if you square both sides. If you square both sides, that's what you're going to get. And this simply means x squared equals 289 minus 225, which simply means x squared equals 64. And that means x equals 8 or x equals minus 8. So those are the possible values of x. Now question B says find the directions of the forces correct to the nearest degree. Let F1 be 8i plus 15j and F2 be minus 8i plus 15j. Now, how do we find the direction of F1? Let me sketch it first of all. That makes it a lot easier to find its direction. Now, this is the y-axis and this is the x-axis. So 8i plus 15j is going to be somewhere around here. This is F1, which is 8i plus 15j. Now that simply means the vertical component of F1 is 15 and its horizontal component is 8. So I can simply say now the direction of F1 is the counterclockwise angle which it makes with the x-axis, and that's this angle. That's the angle. The counterclockwise angle which F1 makes with the x-axis is its direction, and that's it. Now how do we find the angle? Let me call it theta. Tan theta is going to be the vertical component of F1 divided by its horizontal component, which is 15 over 8. So theta itself will be the tan inverse of 15 over 8, and that's the same as, that is the tan inverse of 15 over 8, which is the same as, let's check that, tan inverse of 15 divided by 8. That's 61.928, which is approximately, they said we should leave our answer correct to the nearest degree. That's approximately 62 degrees. So the direction of F1 is 62 degrees. Now how do we find the direction of F2? F2 is minus 8i plus 15j. We can sketch that too. This is what it will look like. That horizontal axis, while this is the vertical axis, y. Minus 8i plus 15j is going to be somewhere around there. Now, this is the force F2, which is equal to minus 8i plus 15j. This is its vertical component. This is the vertical component of F2, F2y, while this is its horizontal component, and I call it F2x. So let this angle be alpha. The direction of the force F2 is actually the counterclockwise angle it makes with the positive x-axis, which is this yellow angle. So when we get alpha, we just subtract it from 180 to get the direction of F2. So tan alpha is F2y divided by the horizontal component of F2. Vertical component divided by horizontal component. f2y divided by f2x, and that's simply 15 over, we don't need to write minus 8 for the horizontal, we just write 8. That's only to show direction, and we already showed the direction in the diagram. So that means alpha itself is going to be the tan inverse of 15 over 8, which is going to be the same as what we got earlier, which is approximately 62 degrees. Now the direction of f2 is therefore direction of the force f2 is therefore equal to 180 minus alpha, which is 180 minus 62, and that's 118 degrees. So the directions of the forces are 62 degrees and 118 degrees. Now we go straight to the next, which is number 2. The position vectors of points P, Q, and R are respectively. Oh, okay. I think I'll come back to that. Yeah, let's come back to that. I don't think this question is complete. Let's come back to that. All right. I'll catch you in the next. Thank you.